Hello everyone. Today I am demonstrating a solution that automates the critical link between threat intelligence and threat detection. Before we jump into the live demo, let's look at the two platforms we are connecting. The first is MISP, Malware Information Sharing Platform. It is an open source threat intelligence platform that allows organizations to share knowledge about malware, malicious domains, and attacks, etc. It's where the security community essentially says, watch out for these specific indicators. On the other hand, we have Google SecOps. This is a cloud-native security analytics platform that ingests massive amount of telemetry and allows you to search through it in milliseconds. It uses entities, the indicators of compromise. We provide this to flag suspicious activity across your organization's log. Our project automates this flow. It continuously pulls malicious data from MISP, transform those indicators into the Google Unified Data Model in entity format, and pushes them into your SecOps instance for immediate detection. So this is how our main flow of the application is. Now let's review the prerequisites to use this application. So you need a MISP instance. From MISP you'll be needing the URL and the API key, which is mentioned here. And same for the Google Cloud. You'll be needing a service account with Chronicle API and your customer ID from the admin console, and you should be having Docker installed on your local machine or server. Now let's move to the next step, that is installation. Setting up the project is straightforward. Start by cloning the repository into your workspace using the git clone command, or you can download the zip file and extract it. So both the ways are mentioned here. You can follow these steps. Once cloned, the workspace contains everything you need: the core logic, configuration templates, and the Docker environment for a seamless deployment and running of the application. Before starting the application, we need three pieces of information. First, from Google Cloud Console, obtain your service account JSON key and save this file as a credentials.json in your project's root directory. So these are the steps mentioned here to obtain the service account JSON key. And the second, grab your customer ID from the Google SecOps setting. And the third one is generate an auth API key from your MISP instance under the administration tab in that list auth keys. You'll find this auth API key, create one, or you can use your previous API key and you're good to go. Next, we configure the environment. We provide an env.example template. Simply copy it to a new .env file or use this command as per your operating system and fill in your specific values. So these are the values that we have it in our .env file. You'll see a config.json file. This handles the default application settings such as batch size, fetch interval, and historical polling depth, etc. You can modify this file directly or use CLI arguments, which we will demonstrate shortly. Let's see the application in action. So these are the steps mentioned here to build and run the application and to view the logs, and also how to stop the application. And below you can see these are the checks through which you can verify that the application is running successfully. I have already cloned the repo and set up my environment. I'll run the build command that is shown in the readme file. And hit enter. Once the build is complete, I'll start the application using the docker compose up command and hit enter. Notice the startup banner. The application validates its configuration and establishes a secure connection to the MISP server. This log shows that the application is running successfully. In a live environment where there might not be a new indicator at this exact moment, you can see the application will wait for the next cycle. In here, the next cycle will start for after 60 seconds. However, for this demonstration, I have pre-synchronized sample data so we can see the results in Google SecOps immediately. To verify the ingestion, we can run a UDM search in Google SecOps platform by searching for a specific host name from our MISP data. So in this search box, you just have to add this query which is mentioned in the README file. Here, this is the query. Just copy it and paste it here. Add the specific host name here and hit on run search query. You can see that our indicators are now live and populated with the metadata we extracted from MISP. And more importantly, our final result, if we check in IOC matches tab, that is under detection in alerts and IOC, we can see that the Google SecOps has already begun correlating our incoming logs against the new indicators. Here, this is a sample data. As you can see, the SONet here, it has been correlated and the match is found through the event and it is listed in the IOC matches tab here. Any match here will trigger an automatic alert. And one important note, alerting occurs within a specific interval, start and end time. Here is that start and end time that I'm mentioning about. You can see here in interval. So the alerts are only generated if an event happens in between this specific time period of start and end time while the indicator is active. Once this time period is expired, the indicator will no longer trigger new alerts. So this is one point to be noted. Our application also supports configuration updates on the fly by using the CLI. I can list the current configuration values on which the application is running and this command to get a specific value. To update the configuration values, you can use any of this command here. The forwarder batch size without restarting the converter. I'll show a quick demo of this command. Here, I'll just open a new terminal, paste the command here. Now let's change the batch size to 50. Here, the configuration is successfully updated. You can explore all the remaining commands here. It will work the same to update the configuration and same for the other commands below like health check, monitoring, view logs and other. And keep in mind that there is a slight delay in Google SecOps while it processes new indicators and correlates them with the events. And lastly, if you run into any issues, so here I listed some common issues. If you run into any one of this, you can follow this step to successfully resolve that issue. By automating this bridge, we move from manual entry to productive defense. This forwarder ensures security platform is always armed with the latest global intelligence. Thank you.